Good evening, all of you. So we have studied, we were looking into this GTPC protocol, and we introduced all the messages and all that, and we have studied some basics about the protocol. And then we yesterday have completed these generic messages also called as echo request, echo response, and version not supported. And today now we are going to start with the other set of messages starting from the create session request onwards, which create session request travels from MME to P gateway, MME to S gateway, S gateway to P gateway. It travels and so for what purpose we use these messages and what will happen as part of these messages. We will be looking into it one by one, all these messages. Okay. So create session request message we have. What is the direction of this message? It travels from MME to S gateway, S gateway to P gateway, and all SGSN to S gateway to P gateway, depending on the mobile equipment's present position. So MME sends create session request to S gateway forwards the same thing to P gateway, reply comes back. That is the um, positive case from MME. Similarly, it can happen from SGSN also. So as I told you yesterday, this procedure is creating a coordination between three components: MME, S gateway, P gateway, or SGSN, S gateway, P gateway. In which scenarios typically this procedure will be triggered? It will be triggered by MME at the time of mobile equipment is attaching for the first time, or if the mobile equipment is connecting to a packet data network PDN. So in such scenarios, MME will be triggering this procedure. Whether the mobile is connecting to the LTE network, even at the time of connecting to the LTE network also, mobile must be connected to at least one PDN, one packet data network. Or even after the initial attach is completed, mobile can add additional PDNs. Mobile can get connected to additional packet data networks. So in any of those scenarios, of course, there are much more scenarios actually in which this procedure gets initiated. I have only listed two cases here for LTE scenarios, and in UMTS scenario, we have listed one scenario, that is PDP context activation. PDP context activation is almost like connecting the mobile equipment to a PDN by creating the EPS bearer. In UMTS, we call it as a PDP context activation. In LTE, we call it as a bearer activation or default bearer creation. We would be using that terminology. So what this create session request procedure would do. If you remember this thing that we have studied, if the mobile equipment is attaching to the LTE network and connecting to a PDN for the first time, at least if you take a default bearer, then the mobile equipment should have at least a default EPS bearer, which contains radio bearer plus S1 bearer plus S5 S8 bearer. So at the time when the mobile equipment is connecting to the LTE network, then the purpose of this, the procedure is initiated by MME, and MME, S gateway and P gateway need to coordinate. They have to create the required control plane tunnel IDs at the end of this procedure, or they have to create, they also need to create your, your user plane tunnel IDs as well. They have to create, so that ultimately this procedure will be triggered by MME towards the S gateway to create all the required control plane tunnel IDs and user plane tunnel IDs. So the create session request procedure. So when we look into this procedure in detail, this is how it is going to be in detail. So we have totally, we are considering 4 components over here. In node B, MME, S gateway and P gateway. We have 4 components in play working. Okay, next what? um, where it gets triggered from the create session request procedure. It gets triggered from MME. Once MME authenticated the user and activated the security, verified the IMEI number, and the MME gone to talk to HSS and gathered the subscriber information. Once all those basic steps are completed, MME starts triggering this procedure called as create session request. It starts triggering the procedure. So at the time when MME is sending the create session request towards S gateway, MME is supposed to use the tunnel ID that is created by S gateway. But because this mobile equipment is just coming up for the first time in the network, and before this, there was no mobile existing, so S gateway wouldn't have created a tunnel ID for this mobile. So when MME is initiating this protocol message, create session request, it will be sending that create session request message by creating its own tunnel ID for receiving the signaling messages from the S gateway. It will include this TEID details, MME S11 GTPc TEID details. It will include in the protocol message called as create session request, and it sends out the message to the S gateway on tunnel ID 0. It will be sending to S gateway. So in the header, tunnel ID will be present, but the tunnel ID will be set to 0, representing that MME representing S gateway that because I'm using tunnel ID 0, I'm trying to tell you that this is a new mobile phone. This is a new user who is actually attaching to us. I must use the tunnel ID that you have created for this user, but because till now you never created any tunnel ID for this user, I'm using 0, indirectly representing or explaining you that this is a new guy. That's the idea. That is the meaning of create session request here. That's the basic idea. Okay. Um, but when S gateway is going to reply back to this create session request message, it is mandatory for S gateway to use the tunnel ID created for this mobile by MME, which is the tunnel ID. This is the tunnel ID. So reply must be coming back on the tunnel ID created by MME. So for that reason, what does MME do is in the header portion, it will use the tunnel ID as 0. But in the IEs, in the information elements that are present in the create session request, MME will include its tunnel ID details and send it to S gateway, telling the S gateway that because I don't know the tunnel ID that you are going to create in the future for this mobile, I am using tunnel ID 0 in the header. But whatever the tunnel ID I have created for this guy, I'm giving it to you in the form of IEs. From next time onwards, you are going to speak to me related to this mobile. Don't use tunnel ID 0. Please use the tunnel ID that I have just created and I have informed you about it in my IEs information elements. That is how MME sends this message, create session request to S gateway. What does S gateway do? S gateway need to forward this create session request message to P gateway. Before forwarding it, S gateway will create one GTPc TEID on his side, control plane TEID on his side. It will create one TEID for receiving the signaling messages from P gateway. Of course, P gateway doesn't know these tunnel ID details. S gateway need to communicate with the P gateway about these tunnel ID details. But S gateway also creates one GTPu TID for the purpose of creating a S5S8 bearer. So it will create one GTPu TID, one GTPC TID. And by including both these details in the form of an IEs, information elements, S gateway will forward create session request to P gateway by using tunnel ID 0 in the header. Why again it will use tunnel ID 0 in the header? Because this is a new guy. P gateway never created any tunnel ID for the mobile user. So S gateway don't know what is the future tunnel ID that the P gateway is creating. That is why it has to send the reply back. It has to send this create session request message to P gateway by using tunnel ID 0 representing P gateway that this is a new guy for whom I have created one control plane tunnel ID, one user plane tunnel ID. If you want to send any signaling messages for this mobile, you send those signaling messages on this tunnel ID. If you want to send any user data for this mobile user, you send that user data in the downlink direction on the GTPu tunnel ID I have created. So there is a GTPu tunnel ID for user traffic. There is a GTPC tunnel ID for receiving signaling messages. Both will be included in the IEs, information elements of this message, while sending to P gateway. P gateway receives this, and P gateway confirms the situation with the PCRF. Once that is completed, P gateway going to reply back. But before P gateway starts replying back, first thing P gateway does is create a S5 GTPC TEID. It will create one control plane TEID on his side. Then also P gateway creates one user plane tunnel ID as well for S5 interface to receive the traffic from the S gateway. So it will create a signaling tunnel ID for receiving signaling messages and user plane tunnel ID for receiving user data. By including both these details in the create session response message, P gateway will send the reply back to S gateway. But this create session response will be sent on a tunnel ID that is created by S gateway earlier. P gateway won't use the tunnel ID 0. P gateway will be using the tunnel ID that is created by the S gateway already, which is conveyed in this create session request message. It will be replying back to the tunnel ID, telling the S gateway that, hey man, for this user to whom you have created this TEID, I'm sending a positive response back to you. In this response, I'm in the header, I'm using the tunnel ID that you have suggested me to use for this user. I'm using the tunnel ID. Fine. But let me tell you one more thing. I have added some information in the information elements. In those information elements, I have added my control plane tunnel ID and my user plane tunnel ID. If you want to send any uplink user plane traffic, you send it to me on my tunnel ID. I have included those details in the response. Also, I have created one control plane tunnel ID, attached it here in the IE. From next time onwards, if you want to send any messages related to this particular mobile user, don't send those messages to me on TEID 0, tunnel ID 0. Don't send those things on TEID 0. Earlier, you have sent it to me on tunnel ID 0. That is perfectly acceptable for me. No problem at all. That is perfectly acceptable. But next time onwards, don't use tunnel ID 0 because I already have created a tunnel ID for this mobile user. You don't need to use tunnel ID 0 next time. I can recognize this mobile if you quote me this particular tunnel ID, which I am sending you in the response message in the form of an IE. So it responds back to S gateway. What does S gateway do? S gateway creates one control plane tunnel ID. It creates one control plane tunnel ID immediately, and uh, for which interface? S11 interface for receiving the signaling messages from MME for this particular user. It will create one tunnel ID. Along with the tunnel ID, it will also create one user plane tunnel ID to receive the traffic from the eNode B. It will create S1 GTPu tunnel ID for receiving user plane traffic. By including both these tunnel ID details in the create session response, S gateway will send that create session response to MME. Of course, it won't be sent back with the tunnel ID 0. Instead, S gateway will be using the tunnel ID that is already created by MME and provided to him in the create session request message. It will use that tunnel ID and send the message to MME. This is the response message I am sending to you, create session response. So I have included my both control plane tunnel ID, user plane tunnel ID details in this response. So if you see the overall procedure, this create session request and create session response procedure, it is creating a lot of tunnel IDs for the mobile equipment who is connecting to the LTE network. It is creating a pair of control plane tunnel IDs on S11 interface, a pair of control plane tunnel IDs on S5 S8 interface, and a pair of user plane tunnel IDs on S5 S8 interface, and one tunnel ID on the S1U interface to open up towards eNode B. eNode B is not yet involved in this procedure. eNode B is about to do that procedure and complete his duty of creating the tunnel for S1U interface for receiving the downlink traffic. eNode B need to complete that job. But by the time this create session request procedure is completed, here we have two signaling tunnels, another two signaling tunnels, two more user plane tunnels, and one more user plane tunnel. Totally, seven tunnel IDs have got created across the spectrum across these three components: MMES gateway and P gateway. Some of them are control plane tunnel IDs, some of them are user plane tunnel IDs. So the whole purpose of this create session request and response, it is a tunnel management procedure. The whole purpose is to create the required tunnels for the mobile user. Those tunnels are control plane tunnels as well as user plane tunnels. Now, what does MME do after receiving this response? MME starts communicating with the eNode B, ask eNode B to create initial context setup request. We have already studied that in S1AP protocol. It will send initial context setup request to eNode B, ask eNode B to create radio bearer plus S1 tunnel. It will ask eNode B to do that. And eNode B first will create the radio bearer towards the mobile by issuing RRC connection reconfiguration. After that is completed, eNode B will also note down the S gateway tunnel details in this message that is coming from the MME. S gateway tunnel details are going to be included because S gateway already sent these two tunnel details in the response. So MME knew these two tunnel details. MME won't forward control tunnel ID details to eNode B, but it will definitely forward the GTPu tunnel ID details to eNode B in the message called as initial context setup request. It will be sending to eNode B. So eNode B note down the S gateway's tunnel details for sending the uplink traffic on the S1U interface, and it will create a radio bearer first. After radio bearer is successful, eNode B will be creating the user plane tunnel towards the S gateway. It will be creating. So, what does eNode B do? It will create the user plane tunnel ID for receiving the downlink traffic from the S gateway. eNode B S1 GTPu TE By including these tunnel ID details, eNode B will respond back to MME. It sends a response back to MME explaining that I have successfully created the radio bearer plus S1 tunnel. I have created the ERAV required. It will inform to MME. What does MME do? MME will have to forward a message to S gateway called as modify bearer request, which we'll be studying a little later. In this modify bearer request, MME will inform to the S gateway by using the S gateway already created tunnel ID. It will be sending this message to S gateway. Hey, for this so and so user for whom you have created this TEID, I am sending a modify bearer request informing you about the tunnel ID that is created by the eNode B. Please note it down. Please, if you want to send any downlink traffic towards the eNode B, you have to send the downlink traffic on this particular tunnel ID created by the eNode B. MME informed to S gateway. S gateway will reply back to MME that thank you very much for reporting me that information. So now we see S1 tunnels are created both for uplink and downlink, and S5 S8 also created for uplink and downlink. So which tunnels are for uplink, which tunnels are for downlink. If any data arrives from the mobile to eNode B forwards the traffic to S gateway on this S gateway created tunnel ID because we use tunnel IDs always for receiving. So eNode B will use it and send it to S gateway. S gateway will use this tunnel ID and send it to P gateway. This is for uplink operation. If P gateway is receiving any traffic from the PDN packet data network, it packs that into this tunnel ID and send it to S gateway. Yes, gateway will pack that into this tunnel ID and send it to eNode B. And the downlink, eNode B will be sending that information to mobile on the radio bearer in the downlink direction. So we have created both uplink as well as downlink. So we have at the time when the mobile equipment is connecting to the LTE network, we have successfully created the needed EPS bearer for the mobile, which is nothing but a radio bearer plus S1 bearer plus S5 S8 bearer. But by backtracking two steps, without including this modify bearer request and initial context setup request, etc., by just going back a few steps here, um, if you just purely study the create session request and create session response part, This create session request and create session response parties to create the required control plane tunnel IDs and user plane tunnel IDs for the mobile equipment to help the mobile equipment to attach with a LTE network by connecting to a PDN, packet data network. Because when mobile is connecting to a packet data network, it is mandatory for the mobile equipment to have user plane EPS bearer. So you must have a radio bearer plus S1 bearer plus S5 S8 bearer. And as part of this create session request and response, we are creating the necessary bearers on all the possible interfaces. Except eNode beside downlink tunnel, almost all the tunnels are created with this single procedure, both control plane tunnel IDs as well as user plane tunnel IDs. Saurav, what is it question? We are studying for downlink condition. I never told you that we have studied for downlink condition. It is for both uplink as well as downlink. Like, how did you get to the opinion that we are studying for downlink condition? Is there anything I have said to that effect? No, it is not only for downlink. We are doing it for both directions. So if you go back, so this create session request and response that gets exchanged between MME to S gateway to P gateway back to S gateway back to MME creates all the needed tunnels, control plane as well as the user plane tunnels. So this is the situation like when the mobile equipment is connected to a single PDN, these many tunnel IDs need to be created. So white, two tunnel IDs white, another two tunnel IDs white, two tunnel IDs aqua, another one tunnel ID here. Totally how many tunnel IDs we are creating are seven in total at the time when the mobile equipment is connecting to a single PDN. If you take the scenario where mobile equipment is connecting to multiple PDNs, for example, if mobile is connected to a second PDN, at the time of connecting to the second PDN, what need to happen? That time, again, the create session request will be sent to create additional tunnels between S gateway to P gateway on the control plane. Of course, with every increasing bearer, user plane tunnels will be increasing for every increasing bearer. But we are specifically studying the create session request, which will be originated only at the time when the mobile equipment is attaching to the LTE network for the first time and connecting to its first PDN, or it is connecting to the additional PDNs at any time after already connected. So at this stage, when the mobile is connecting to an additional PDN, that time on S5 S8 interface, we need to create additional control plane tunnels, as well as for a default bearer, we need to create user plane tunnels as well. But we won't be creating any additional control plane tunnels between MME to S gateway. MME to S gateway, we have only one set of tunnel IDs, irrespective of whether mobile is connected to a single PDN or multiple PDNs or two PDN, three PDNs, doesn't matter. We are going to have only one set of tunnel IDs here on the MME. Only between S gateway to P gateway, the tunnel IDs will be increased depending on the number of PDNs that you are connecting to. Okay. Now we are going to look into the actual protocol messages one by one and the I information elements that are present inside this each of these messages, like create session request, etc. So first message we are looking into create session request IEs. We already have studied the header part. Now we need to look into what IEs will be present, what parameters will be present inside that message, uh, prepared and sent by MME to S gateway or S gateway to P gateway. So at the time of studying this IEs, we will be concentrating on both uh, aspects. Like we will be studying this message from two point of views. When MME sends it to S gateway, what IEs will be present. When S gateway is sending it to P gateway, what IEs will be present. We will be looking into both of the aspects. Okay, so when the MME is originating it to S gateway, it will include IMSI number, MSISDN number, and IMEI number of the mobile, and mobile's present location details, like where the mobile is presently in which tracking area, or if the mobile is presently present under UMTS network routing area, and if the mobile is present in LTE network, in which cell it is present, in which tracking area it is present. MME is sending all these details to S gateway. S gateway also will include all these details and forward it to P gateway. On both interfaces, these IEs will be present. So mobile's permanent IDs, whatever that are quoted by the mobile, your permanent IDs, IMSI, MSISDN, and IMEI numbers, and as well as mobile's present location, including which network is serving the mobile, and what is the radio access technology that the mobile is using, LTE or UMTS or whatever, like that, all the details about the mobile. This is one set of IEs that will be present, information elements. Here, C stands for conditional. Conditional means depending on the situation. We'll, we may either decide to add this information element or we may decide to ignore it. Conditional ones are optional basically. It may be present, may not be present, depending on the conditions. What is the condition? The conditions are written here in these boxes. For example, if mobile equipment is performing something called as a emergency attach without having a SIM card. If mobile is not having a SIM card means MSISDN won't be there, IMSI won't be there. Mobile will be quoting his IMEI number for the registration for making a emergency call. That time the IMEI number sending is a must. We will not be having MSISDN sent, we will not be having IMSI number sent in case of a emergency attached scenario. So the conditions will be written here, which explains which IEs will be present in different situations. You don't require to attach all the IEs all the time. You require to attach the IEs depending on the need, depending on the activity that is going on. All right. There are some indication flags. We already know what is the meaning of a flag. Right now, the flags are not part of the header in GTPC, not only part of the header in GTPC, but there are some flags that will be attached in the form of an IE also. In fact, here we have 8 flags attached in the form of an information element explaining about 8 different features, whether we are using those features or not. So depending on whether we are what we have to explain the other component, we will be using these features. For example, if one GTPC component explaining to the other GTPC component about whether piggybacking is supported or not in its first message, it can report that. If he says that piggybacking is not supported by setting the value to 1, by setting the value to 0, that means you are telling the other guy that you must send the GTPC messages independently. You are not allowed to do the piggybacking because I don't support it. It is that kind of a mechanism. But if he says that I support piggybacking, then the other component can send small GTPC messages combined together, and we can send it as a single big message. We can separate them out. We have that technical availability, so we can separate it out. So like that, what are the different flags required in different operations? So for every flag, the possible values are going to be 0 or 1. So total number of flags we have are 8. So we have represented those things with 8 values. For example, if the mobile equipment is making a emergency attach, that time we will be including unauthenticated IMSI. That means even though the mobile is having the SIM card, but the SIM card is not validated because he is trying to make an emergency call. So we don't care whether the mobile SIM card is genuine or not genuine, or whether it is having is subscription active or not. We don't bother about all that. That represents unauthenticated IMSI. So typically presented in case of emergency attached UAs. So that means we are sending IMSI, but we are sending IMSI, we are telling that this IMSI is not authenticated IMSI. This IMSI is unauthenticated IMSI because he is performing emergency attach. So I have, given some leeway here, and mobile was not authenticated. His IMSI was not authenticated because as me making emergency call. So that's the kind of stuff. If the same message is coming from the S gateway, this parameter makes sense. For example, direct tunnel flag. The flag shall be used on S4 interface to report that direct tunnel between S gateway to RNC is allowed. That means S gateway can start sending the traffic to S gateway can start sending the traffic directly to RNC. RNC is capable of sending the traffic directly to S gateway by using by using an interface called as S12. So your SGSN is reporting to S gateway whether S12 interface is supported or not supported, whether your RNC supports that technology or not. So that is a direct tunnel solution on S12 interface included on S4, basically reported by your SGSN. Some more IEs, the lot of IEs are going to be there inside these messages. Sender FTEAD for the control plane. FTEAD is nothing but TEAD itself. TEAD for the control plane. Who is the sender? Sender could be two guys for this message, create session request message. When it is traveling from MME to SGSN, it is SGSN is the, sorry, my mistake. If it is going from MME to S gateway, um, MME is the sender. When it is going from S gateway to P gateway, S gateway is the sender. That means a sender TAD for control plane. That means either it is going to be MME's control plane tunnel ID, S11 tunnel ID that MME created. When MME is sending it to S gateway, that will be included in this field. When S gateway is forwarding the same message to P gateway, S gateway's tunnel ID details will be included in this message, sending it to P gateway. So that is the meaning of sender FT ID for control plane. Okay. Um, P gateway's S5 S8 address for control plane or PMIP. This is required in case of some special interface working on S5 S8 interface with PMIP mechanism, proxy mobile IPv6 mechanism that we'll be learning later. So we'll ignore this IE for some time. Access point name APN, the mobile equipment is connecting to which access point name. What is your connecting point to the PDN? Selection mode and PDN type, whether mobile is interested to connect it to IPv4 network or IPv6 PDN or mixed one IPv4 IPv6 network, which one it is. So that is the PDN type. And PDN address allocation. What kind of IP address mobile equipment would like to get? Whether mobile wanted to get a fixed IP address or whether mobile wanted to get a dynamic IP address, that kind of details will be here. PDN address allocation, what kind of IP address mobile is looking for, a static IP address or a dynamic IP address. So there are multiple options available. In IPv6, there are going to be three options. In IPv4, there are going to be two options. Out of all those many options, mobile will choose what option it would like to get the IP address in. Because P gateway is responsible for the IP address allocation. So indirectly, MME is sending this information to S gateway. The same thing can be forwarded from S gateway to P gateway also, explaining what kind of IP address is preferable for the mobile in your IP technology networks, as a static IP address or a dynamic IP address, etc., etc. In case of IPv4, you will have two types of IP addressing. One is called as a static and the second one is dynamic. In case of IPv6, you will have static and you will have dynamic and you will have something called as, um, um, you know, what is that? I'm not, um, uh, what is that word? I have forgot the word in uh, auto configuration. Basically, it is called as stateless auto configuration. I forgot that stateless word. Okay. So you have three different methods we can allocate the IP address in IPv6 case. So that option will be set here. For example, if you are choosing IPv4 here, you will be choosing one of the two things. In the PDN type is IPv4, then you will be choosing one of the two. If PDN type is IPv6, you will be choosing one of these three. If you choose IPv4, IPv6, we will choose one method in IPv6, we will choose one method for IPv4 because you will have both IP addresses when you are connecting to IPv6, IPv4 v6 network. Mobile will be allocated with the two IP addresses, not one IP address. You will get one IPv6 address, you will also get one IPv4 address. To connect to the IPv4 based servers, you will use IPv4 IP address. To connect to the IPv6 based servers, you will be using IPv6 address. If you choose IPv4, IPv6, it will be dependent on your PDN type, how many IP addresses you need to get, single address or multiple addresses, and what kind of address you prefer. Maximum APN restriction, another parameter we have here, and aggregate maximum bitrate that is received from the HSS. So we are sending it for the approval from your PCRF. MME sends it to S gateway. S gateway will forward it to P gateway. P gateway will approve this aggregate maximum bitrate from PCRF. Asks PCRF for this mobile, can we use this aggregate maximum bitrate? If PCRF accepts it, we continue with this aggregate maximum bitrate. Otherwise, PCRF can change this also. Um, Along with this tunnels that we are creating in the control plane, are we going to create any tunnels for the user plane? So that is your linked EPS bearer ID. We have the EPS bearer ID, nothing but your default bearer ID. Typically, the default bearer ID at the time when the mobile equipment is connecting is 5. Default bearer ID will be, it is normally the value that we use for any bearer ID, 5. That's the default value. And there is some protocol configuration options which we have ignored earlier and we are ignoring now also. We'll be learning that later. What is this protocol configuration options? And there is a bearer context to be created, information element, which is also called as a grouped IE. This is called as this bearer context to be created is a grouped IE. What is the meaning of a grouped IE? Inside this one IE, there will be a lot of IEs will be present inside it. So several IEs will be part of this particular message, this particular one IE. So the IEs inside IEs are actually called as grouped IE. So this bearer context to be created is a grouped IE. Similarly, if required, in some special scenarios, at the time of mobile equipment attaching for the with the network freshly, if the mobile is already having some attachment already happened earlier, that attachment related things will be removed at the time when the mobile is doing a fresh attach. So you will create fresh bearers and remove the old existing bearers at the same time. But this is conditional. It may be there, it may not be there, but this is mandatory because at the time of when the mobile equipment is attaching to the LTE network or when the mobile is connecting to a new PDN, creating the EPS bearer is mandatory. It's it's a must. So this parameter will always be present. This IE will be present. What IEs will be there inside this IE? We will again see that once we complete the main list, we will expand this once again. We have some more details, whether the mobile trace is activated or not. What is the ongoing recovery parameter value on the node, like how many times the node is restarted. Only for the first time we are sending a GTPC protocol message, we need to include this recovery parameter. Otherwise, you don't need to send it every time. You don't require to send this recovery value. So it is conditional. It will be dependent on the condition that you are talking to that component for the first time or you have already communicated. For normally, MME and S gateway will be communicating forever. So only one time they will be sending this recovery value between each other. After that, they will not be exchanging it, because recovery parameter is anyway part of echo request, echo response. Whenever there is no traffic going on between two components, that time the components will be exchanging recovery. We don't need to send that as part of the primary protocol messages. And um, for every mobile will be part of a CSID in MME, and every mobile will be part of another CSID in a S gateway. So they can create lot of CSIDs, which are basically user groups. Basically, so if there is any hardware goes wrong, MME will report that so and so users with this particular CSID are impacted. To do such kind of failure related mechanisms, they will be using the CSID concept. For example, MME and S Gateway are talking to each other about 5 lakh users. They might have created 50 CSIDs. Under one CSID, you may have 10 lakh users, for example. Um, so sorry, 10,000 users. So if one processing unit has been shut down on the MME out of 30, 40 processing units that are present, MME will go and tell the AS gateway that you remember I have created CSID for every user, and now the CSID number 5 has got impacted because of my hardware failures. So all the users with that CSID that I have created, all those users data is impacted on my side. You guys also have to throw the data into dustbin, forget about those users. When the um, when those users will try to do the attach once again, we will deal with them freshly, but right now I have lost their data. So to do that kind of failure mechanisms, they will be using this CSID, like they will create a CSID for every mobile. For a lot of mobiles, the same CSID could be used. For example, for today continuously, MME might be using CSID number 107 for all the users created for the next 3-4 hours, because all those users data is stored in one processing unit itself. You might be creating only one CSID for them. Once that processing unit is already overcrowded, you are shifting the users traffic to another, you are creating the new connection related details for new users on a different processing unit. Then you might have a new CSID. It is like intelligently grouping the mobile users, so that in case when the hardware failures occur, they, instead of throwing all the mobiles information, they can identify which mobiles information has been impacted, and only those users information will be removed, and rest of the things will continue as it is. So this is for failure cases. And UE is presently under which time zone? What is the charging characteristics that are applicable for the mobile received from the HSS? Of course, these charging characteristics must be validated by PCRF. And whatever PCRF is approved or agreed upon, that will be your final charging characteristics. But this is the information MME got from HSS. MME is sending it to S Gateway. S Gateway will send it to P Gateway. P Gateway will confirm that with your PCRF by using your S7 procedures, whether these charging parameters are okay or not. And there is a private extension optionally, may be present, may not be present, general information on that particular protocol interface, which most of the time will be ignored. It is non-technical information, this private extension is. So these are the IEs present in create session request when it is triggered from MME to S gateway, further S gateway to P gateway. Along with this, we have studied this bearer context to be created and bearer context to be removed. Both are grouped IEs. So for these grouped IEs, the information will be present like this. Bearer context to be created. So what is the EPS bearer ID we are creating? What is its traffic flow template values? If you already knew the eNodeB tunnel ID or SGSN tunnel ID or any of these details, you will be including those tunnel ID details. Or when S gateway is forwarding the same message to P gateway, then S gateway tunnel ID details will be present inside it. When S gateway is sending it to P gateway, the user plane tunnel. These are all user plane things basically. So all user plane related tunnels on different components, and what is the quality of service with which the bearer is getting established, and some more bearer flags related information. All these IEs are going to be present inside this big IE called as bearer context to be created. So it is like bearer context to be created is a is a combined parameter which is containing a lot of parameters inside. It's like that. But when it comes to bearer context to be
Uh,
deleted, yes.
Excuse me, sir. Actually, I have one doubt that for user plane, when tunnel is creating, when it is we create two tunnels or one tunnels. Actually, in your first diagram, it is showing one tunnel, and
Yes,
in
only one
description,
tunnel.
it is showing two tunnels. But in your the detailed description, you are showing that is showing two tunnels. First for
No, it
from
is not two
SGW.
tunnels. It is not two tunnels. It is only one tunnel that will get created. You got confused. At one place we have only the ID present. For example, this is bearer context to be created. This is just a linked EPS bearer ID. Here it is only ID. Only information that will be present is in the bearer context to be created. That's all. If this bearer context to be created, you will have information related to
Uh,
one tunnel only.
Not here, sir. Actually, in your diagram, where that ID is created, you showed two tunnels actually in previous
Okay.
diagram.
This is user plane, and the control plane tunnel part I have already showed you as part of this year. This is where you missed it. I've told you that sender FTE ID for control plane. This is control plane tunnel ID. C plane is your signaling tunnel
Not
ID.
here, sir. Actually, I am asking that diagram which
I'm
you
relating
showed.
that to here because you're
Yeah.
confusing, right? That's why I'm relating. This is control plane tunnel ID details. And the second one is this is the user plane tunnel ID details. This is the user plane one. So are we creating two things or not? We're creating two things. Yes,
Sir,
it
can
is.
we go in that diagram
Okay, I'll go back to the
once?
data. Yes. What is the problem?
Uh, here, actually, two tunnels you are showing here
That is
from E node B to SGW.
node B2.
SGW. Currently, one tunnel is showing. After that, two tunnels showed.
Yeah, we will create a tunnel to receive the traffic from S gateway. After this response is received, and once MME sends the initial context setup request to eNode B creates this tunnel details, and these tunnel
So,
details will be sent in the next GTPC message called as modify bearer request.
so
This is another
that's
GTPC
what
message.
I asked him, sir.
This is another
Sir, it is
GTPC
two
message.
tunnel.
This is another GTPC message.
Okay. But for user plane, it is showing two tunnels. I am asking simple question that it is two tunnel or one tunnel for user plane between email.
Okay, let me tell you that. Let us go back and go to the standard mechanism. For example, I'll go all these steps back. At first, no tunnels. MME created one tunnel ID called as S11 GTPC TE and it'll include that. Sorry, it'll include the tunnel ID information here. Sorry, it'll include the tunnel ID information here. This is that sender FTE ID for control plane. It included here. Now, MME is not creating any user plane tunnel IDs here. MME is not doing it. So, in the bearer context to be created part, MME will be basically including the bearer ID, cause TFT, and most of these things are conditional, means they can be absent as well. All these things can be absent. So only you will be including bearer ID details and what is the cause of the creation. Because you are connecting the mobile equipment to a network PDN, we are asking it to create it. Which EPS bearer ID to be created? This EPS bearer ID. So these details will be attached and sent from MME to S gateway. This package will be part of this particular thing, which is that this is part of here bearer context to be created. This section. Okay, so this is about the user plane part. But anyway, MME is not doing anything related to the user plane one. It is doing only control plane tunnel ID. It has sent a create session request to S gateway. But when S gateway is forwarding it to P gateway, S gateway is creating a tunnel ID at the control plane. S gateway creates a tunnel ID at the user plane and send the same create session request message to P gateway. So when S gateway is sending it to P gateway, in the same message that we have studied, this will be present sender FTEID for control plane containing S gateway's control plane tunnel ID will be here. It will be set here. And in the user plane section, here bearer context to be created, you will have information attached about this thing. The information that will be attached is your S gateway will include this parameter. This tunnel ID will be included. S5, S8 user plane S gateway TEID. It will be created by S gateway, and S gateway will include this in the bearer context to be created section. So when it is coming from MME to S gateway, nothing, no tunnel ID details are there, all are ignored. But when it is traveling from S gateway to P gateway, S gateway tunnel ID details are attached additionally when it is sent to the P gateway. So what tunnel ID we are creating, how many tunnel IDs we are creating? So we are creating two tunnel IDs at this stage. One is control plane tunnel ID and one is the user plane tunnel ID. We haven't yet discussed the response message. In the response message, the remaining tunnels will be created. You did not wait till we study the response message, and nothing happened in the response. So far, we did not even discuss response. Without response, there is no second tunnel that comes into the play. You are imagining in your head, because I have already told you this whole procedure. With respect to response also, I have told you. You are imagining that, okay, that also is part of create session request itself. I wanted to bloody see two tunnels because you told me that there are two tunnels. It is not. Are you getting it? Is this clear so far? Is this understood or is it not
Oh,
understood?
okay, means both the tunnel ID will be shared the same tunnel, right, sir? In
Both the tunnel IDs will be shared with the same tunnel means? What is the meaning of it?
we
Both
mean
control
both
plane
the
tunnel ID, user plane tunnel ID is packed into this message itself in the form of IEs,
okay.
and we send it to P gateway. S gateway is sending that. What P gateway is doing, we not yet seen that because we did not see the response message yet. We have to see that response message.
No, okay, okay, sir.
We did not even see the response message. You already imagined enode B part because enode B part will come into play after the response message goes to MME. But we did not even study to that level. We have only studied this create session request message reaching from MME to S gateway to P gateway. How many tunnels are created? From MME to S gateway, one control plane tunnel created. S gateway to P gateway, one control plane tunnel ID and one user plane tunnel ID get created. And those details are included into this create session request messages. Now we have to study what happens in the create session response, the response message. That is what I'm about to show you. Before that, you have asked the question. So now I'll show you the create session response message that is going back from uh, P gateway to S gateway to MME. What details will be there? First, cause will explain whether this procedure has been accepted or rejected. It will explain that, the cause part. Then it will include the sender FTEID for control plane. So who is this sender FTEID for control plane? What TEID it is? It is a control plane tunnel ID. Whose tunnel ID? If P gateway is sending the reply back to S gateway, then it is going to be the P gateway's control plane tunnel ID. When S gateway is sending the same reply message, create session response reply message to MME, that time this IE will be carrying S gateway's control plane tunnel ID. It will contain that tunnel ID. So in this information element place, it could be P gateway's tunnel ID or it could be S gateway tunnel ID, depending on this create session response is yeah, traveling from P gateway to S gateway or S gateway to MME. It because this same message is operating on two interfaces for us. So if you go back now, if you take to the next level, P gateway will create first one control plane tunnel ID. P gateway will create one user plane tunnel ID for receiving the traffic from S gateway. For receiving the signaling messages from S gateway, it will create one control plane tunnel ID. By including these two tunnel ID details into a message called as create session response, P gateway reply back to S gateway. So in create session response, how many tunnel details will be there? Two tunnel details will be there. One control plane tunnel ID detail will be there. One P gateway, one user plane tunnel ID detail will be there. So if you go back to the response now, so this is the control plane tunnel ID information, followed by what is the IP address that is allocated to the mobile, the IPv4 address or IPv6 or IPv4, IPv6. Are there any APN restrictions applicable for the mobile? What is the aggregate maximum bitrate approved for the mobile by the PCRF? That information is coming from P gateway to S gateway to MME, and what is the linked EPS bearer ID that is successfully created, and we ignoring the protocol configuration options. Bearer context created, which are the user plane bearers that are created successfully. That information is again is your grouped IE. This is grouped IE bearer context to be created, and there is a recovery parameter and charging gateway name, charging gateway address, like your CGF components IP address and name of the component. In some special cases, these details will be required for your S gateway. So P gateway is sending these details to S gateway. This information won't be present when S gateway is forwarding this message to the MME. It will be present on only S5 S8 interface, the CGF related details. And P gateway is also including the mobile equipment into one CSID group for fault management related problems. And also S gateway is also including the mobile into one CSID group and informing it to MME this user belongs to which CSID, and there is a private extension. So these are the typical details that are present. Again, when you look into it, this bearer context created is user plane part. This sender FTEID for control plane is the control plane tunnel ID. This bearer context to be context created or user plane tunnel ID. So when you again look into that bearer context created, in that you will have the EPS bearer ID, cause whether the bearer is successfully created or not, and what is its traffic flow template parameters, followed by your P gateway TEID, S5S8 P gateway TEID when it is sent from P gateway to S gateway, and when it is coming from S gateway to MME, it will contain S1U S gateway TEID. So one of these two IDs will be present. If it is from P gateway to S gateway, P gateway TEID would be present. If it is traveling from S gateway to MME, the same response message is traveling from S gateway to MME, S gateway TEID will be present. When the same message is going from S gateway to SGSN, S4U, S gateway TEID will be there. When the S12 interface is enabled, S gateway S12 TEID will be sent to SGSN. So depending on which interfaces we are activating you on the user plane, corresponding details will be included. So my meaning is, when this create session response message is traveling on two interfaces, so when it is traveling from P gateway to S gateway, these two tunnel ID details are included in it. This tunnel ID, this tunnel ID details. But when the same create session response is traveling from S gateway to MME, what will happen? First, S gateway will create one tunnel ID for control plane. S gateway will create one tunnel ID to receive the traffic from eNode P, user plane tunnel ID on S1. By including these two details, S gateway will send the response to MME, create session response message. It will send to MME. Are you understanding this whole process now?
Yeah, understood, sir.
The whole confusion is because of multiple components are involved in this procedure. There is confusion about what informations are present inside it. But if you just look at it from step-by-step aspect, you will not have any confusion. Now, in the create session response, what does yes gateway do? Yes gateway will include this tunnel ID detail, this tunnel ID details. This tunnel ID information is required for MME for his signaling operations. This tunnel ID is useless for MME because MME won't be using this tunnel ID. Indeed, it needs to be used by eNode B to send the uplink traffic for this bearer. So that means MME understands that I need to forward this tunnel ID details to eNode B. I need to do that. I must do it. So what does MME do? MME decides by sending a S1AP protocol message to eNode B called as initial context setup request. In that, MME will tell eNode B, hey man, I'm telling you what is the S gateway's tunnel ID to you. Note down, bloody fellow. Keep it with you. If you, after the EPS bearer is successfully created, if you want to send any uplink traffic, you have to send the uplink traffic on this S gateway's tunnel ID. Note it down. Also, MME orders eNode be that you please create radio bearer. Also, you please create your own GTPU tunnel and send the details back to me. I want you to create one GTPU tunnel to receive the downlink traffic from S gateway. You must send it back to me. So what does eNode B do? After creating the radio bearer, eNode B creates the GTPU tunnel to receive the downlink traffic from S gateway, informs that information to MME. It sends that. You can see the reverse arrow mark here. It sends it to MME. MME gets to know what is the tunnel ID created by eNode B. What does MME do? MME will send that eNode B tunnel related details to S gateway by using another protocol message. It is not part of create session response. You keep asking me about eNode B as having two tunnels, two tunnels, two tunnels. The second tunnel information is going in another procedure. It is not part of our create session request response. Create session request response procedure is only restricted to this much. Only it is creating this much, these many tunnels, these many control plane tunnels and these many user plane tunnels. The second tunnel from the eNode B is not created as part of your create session procedure. It is happening afterwards in the form of an S1 procedure called as initial context setup request, and also another GTPC procedure called as modify bearer request, which we'll study later.
Excuse me, sir. Hello?
Yes.
Sir, that's your mean second tunnel is for downloading to S gateway
One
to
tunnel
eNode
is
B.
for downloading, one tunnel is for uploading for anybody. It is the case. It is the
Okay.
same scenario. For example, yes, gateway will use this tunnel ID for uploading. Send the data he received from the eNode B to P gateway. It will use this tunnel ID. Uh, to receive the data from the P gateway, it will be creating this tunnel ID, give the detail to P gateway, so that P gateway will be sending the traffic to this tunnel ID. So this is for
Okay,
receiving
sir.
downlink traffic. This is for sending uplink traffic and created by P gateway. It is not created by S gateway. It is created by P gateway. S gateway created the tunnel ID for receiving his data. Same way P gateway created the tunnel ID for receiving uplink traffic from the S gateway. Same way, S gateway created the tunnel ID to receive the traffic from eNode B in the uplink direction. And also, S gateway will use the tunnel ID to send the traffic to eNode B in the downlink direction. That tunnel ID will be created by eNode B.
Okay, sir. Understand. No issue.
So that is the create session request and the create session response procedure, which will be creating control plane tunnels as well as the user plane tunnels. And one more important point here is that at the time when the mobile equipment is connecting to a PDN also, this create session request can be triggered, but the number of tunnel IDs will be creating are only 5. It won't be 7. It will be only 5 because MME to S gateway, you don't need to create a second control plane tunnel set of tunnels. We don't need to create between MME to S gateway. It will be only one set between MME to S gateway in respect to a mobile is connected to how many number of PDNs you would like to connect to. But on S gateway to P gateway, we have to create both control plane tunnels as well as the user plane tunnels. So S gateway to P gateway part, there is no change. All the tunnels that need to be created. But between MME to S gateway, we can skip with the control plane tunnel IDs. But S gateway need to create the tunnel ID towards the eNode B for helping the mobile equipment to connect to a new PDN. Because every time mobile connects to a new PDN, mobile equipment must have a default bearer created towards that particular PDN. It is mandatory. Okay. Now we study these procedures one by one. So the next procedure is create bearer request. What is it? This create bearer request is used for creating dedicated bearer initiated by the P gateway. Default bearer will be created at the time when the mobile equipment is connecting to the LTE network or connecting to a PDN itself with create session procedure. But dedicated bearers are always going to be initiated by the P gateway. So P gateway triggers create bearer request to S gateway. S gateway sends create bearer request to MME. MME sends ERAB setup request towards eNode B. ERAB setup request to your eNode B component. eNode B sends RRC connection reconfiguration request to mobile to create a radio bearer. And once that response comes back, radio bearer creation is done. eNode B, by creating a S1 tunnel, it will reply back to MME that I have done the ERAB creation. Then MME will send create bearer response to S gateway by including eNode B tunnel details. It will send the message to S gateway. S gateway then send the create bearer response to P gateway. So even this is used for creating the tunnels, but this will be creating only user plane tunnels. It won't be creating any control plane tunnels. Control plane tunnels will be created only as part of create session request. It will never be created with any other procedure. But there are a lot of procedures we use for user plane tunnel creations. So this create bearer is one among it. It is only for user plane tunnel creation. For additional EPS bearers, for additional bearers called as dedicated bearer. For example, this create bearer request is for a dedicated bearer creation.
Sir, sir,
Yes.
sir, if there is two PDN,
Yes.
there is two PDN, then total number of tunnel is 9.
You cannot say that. That will be dependent on how many EPS bearers you are having again. It will be dependent on that factor. For example, there could be a lot of different situations when it comes to your number of PDNs you are connected. For example, mobile connected to one PDN here. Number of EPS bearers mobile is having is only one, which is default bearer. So the number of tunnels we totally created are 8, including eNode B tunnel, S gateway tunnel, S gateway to P gateway. There are 4 tunnels totally. 2 control, 2 user. S gateway to MME, we have again 2 control tunnels. Totally, we have 8 tunnels here. With one additional dedicated bearer coming up, again 4 more tunnels will be, tunnel IDs will be added. One by eNode B, one by S gateway, another by S gateway, another by P gateway. So 4 tunnels we need to additionally create. Mobile is still connected to only one PDN. Control plane tunnel ID is not increased. User plane tunnel ID is increased. Again, mobile having another EPS bearer, another dedicated bearer with a new quality of service. So we are creating one more, uh, time we are creating these tunnel IDs, user plane tunnel IDs only been added. Control plane are remaining same. Control plane are not increasing. But when the mobile is connecting to an additional PDN, you will be having one additional set of control plane tunnel IDs getting created on between S gateway to P gateway. Between MME to S gateway, we don't need to create. Only S gateway to P gateway, we need to create. But user plane tunnel IDs remain same. So we need to create 2 user plane tunnel IDs from S gateway to P gateway. S gateway one tunnel ID, eNode B one tunnel ID will be creating for the default bearer connecting to that PDN that will be there. So again, if additional dedicated bearers are coming up, again we have to create user plane tunnel IDs. Control plane tunnel IDs won't increase, but user plane tunnel IDs can increase, decrease depending on EPS bearer establishment and EPS bearer release, depending on that. So you cannot specifically say whether it is 9 or 8 or whatever. It'll be it'll be dependent on different situations, like how many EPS bearers you are having and how many PDNs you are connected to. Depending on all that, the number of tunnels will be created. So this picture is a good example to understand how many different tunnels we require at different stages. So for example, as part of create bearer, what happens? I will explain that. P gateway creates one GTPU tunnel on his side. By including that GTPU tunnel details, it will send a message to S gateway. S gateway will create one tunnel ID towards eNode B on S1 interface, S1U interface. By including that S1U details, it will send a message to MME. MME, by forwarding S gateway's tunnel ID details, by attaching those details, MME sends a message to eNode B called as ERAB setup request by including the S gateway tunnel details. And eNode B will note down that S gateway tunnel details, and it will send a message to mobile equipment called as RRC connection reconfiguration request. And once mobile sends RRC connection reconfiguration response, at the same time, eNode B will be reporting back to MME with ERAB's setup response. In the ERAB setup response, your eNode B will be including the S1 tunnel that it has created for the dedicated bearer. It will include the details and send the response back to MME. What does MME do? MME will include these tunnel details in the create bearer response and send it to S gateway. S gateway will note down the eNode B created tunnel ID details. It will note down. But when S gateway is forwarding this create bearer response to P gateway, S gateway will create one tunnel ID for the purpose of P gateway to send the traffic, and by including that tunnel details in this create bearer response, S gateway will send the reply back to P gateway. So ultimately, the point is we need to create the tunnel IDs. How many tunnel IDs we have created in this example? 4 tunnel IDs. P gateway 1 tunnel ID, S gateway towards P gateway 1 tunnel ID, S gateway towards eNode B another tunnel ID, and the eNode B 1 tunnel ID. Totally 4 tunnel IDs got created. So we have one dedicated bearer got activated right now with this create bearer request procedure. So if you go back to the previous picture that we were studying, the sorry. The previous picture we are studying, now you can just observe this. This is mobile connected to a single PDN with one default bearer only. This is an additional dedicated bearer created. 2 bearers are existing. So how many additional tunnels we had to create? 4. One P gateway, S gateway on S5, S8, one S gateway and eNode B on S1 interface. So 4 tunnels we need to create totally. So the 4 tunnels will get created as part of this create bearer request, create bearer response procedure to activate an additional dedicated bearer. But triggering is happening from P gateway, not happening from MME. Create dedicated bearer triggering always happens from P gateway. That's the idea. Sorry. Okay. So same create bearer request can come from P gateway to S gateway, but it can be routed to SGSN in case if the mobile equipment is right now present under UMTS technology network. So it will be forwarded to SGSN and the response will come back. Similarly, sorry. If mobile equipment demands that I need a dedicated bearer, mobile sends a NAS message to MME called as I need my uplink data sending purpose, I need a dedicated bearer for uplink data sending purpose. Mobile will report to NAS, mobile to report to MME with the help of a NAS protocol message called as ESM protocol message, resource bearer request. It will send to MME. When MME realizes that the mobile is demanding the dedicated bearer, it will send a protocol message to S gateway called as bearer resource command, and S gateway will forward that bearer resource command to P gateway. When P gateway gets it, P gateway understands that typically I'm the one who is supposed to originate the creation of dedicated bearer, but this time the recommendation is coming from the mobile equipment. Mobile might have told this to MME. MME sent this to S Gateway. S Gateway sent it to me. So when I receive this command message, I need to trigger the create bearer request. So this command is to trigger the bearer request. That means P Gateway can trigger this, send this create bearer request to create a dedicated bearer tunnels on his own decision making power, or he can start this create bearer request procedure upon receiving a recommendation with this bearer resource command, especially from MME. When MME got such a request from the mobile equipment in the form of a NAS message, a ESM message called as resource bearer request. So this creating the dedicated bearer can either be a two-step procedure or it can be a three-step procedure. In case it can be working with command, it will be having command, request, and response, a three-step procedure. But if you see the previous step, when the dedicated bearer is getting initiated purely by the P gateway, that time P gateway will be sending create bearer request. Typically, P gateway will trigger this create bearer request to create a dedicated bearer whenever you see huge amount of downlink traffic that is arriving from the application server. P gateway realizes that this much amount of downlink traffic cannot be sent to the mobile on his default bearer. It is the time for upgrading the mobile user from default to dedicated bearer. It will confirm that with PCRF. Once PCRF accepts it, P gateway triggers the creation of the dedicated bearer by sending create bearer request, because he himself realized the need of the dedicated bearer for the mobile on the basis of downlink traffic. But P gateway can never realize this for uplink traffic, because uplink traffic is generated by mobile phones applications. Only mobile phone know how much amount of uplink traffic is getting generated, whether it is needed to have a dedicated bearer or not. Only mobile equipment can know that thing. So only um, only mobile will be able to recommend it to MME. So when mobile sends such a recommendation to MME with the help of a NAS protocol message, MME will send the same recommendation to P gateway in the form of a bearer resource command, and it will go to P gateway. P gateway triggers this create bearer request and response. Okay. But if P gateway tried to communicate with the PCRF to start the creation of dedicated bearer, but if PCRF rejected it for any reason, then what does P gateway do is it sends when it receives the bearer resource command, P gateway replies back with bearer resource failure indication, telling the MME that inform to that mobile phone bugger that you whatever the thing that you are asking for is not possible because PCRF rejected it for any reason. So in case PCRF rejects it, P gateway don't have the permission to start creation of the dedicated bearer. It will be outrightly rejecting it by sending failure indication. So within the timer expiry, we either need to receive this bearer request setup procedure, or we must receive this failure indication. One of the two things must happen before the timer expiry. So even if we study this protocol messages and IEs inside it, the details that we'll find out is related to the tunnel IDs. So every time it is the it is the details related to tunnel IDs. I have not included the IEs much. The message part we are not studying. We are directly studying what is the essence of each and every message. So you can imagine what kind of information elements that will be present inside each of these GTPC messages, because we had to study a lot of GTPC messages. If we start studying IEs, it will take almost 10 days for completing GTPC protocol. So we'll not be spending that much amount of time repeating the same kind of details in every single message, because all the messages will only talk about tunnel IDs, control plane, user plane tunnel IDs. Majorly they'll talk about. Okay. Next, modify bearer request. modify bearer request and modify bearer response. If MME found out that mobile equipment has moved from one eNode B to another eNode B, handover happened, like X2 based handover happened, for example, mobile moved to a new eNode B. When mobile moves to a new eNode B, you will have a new tunnel IDs because new eNode B creates the new tunnel IDs. When new eNode B forwards the tunnel IDs to MME in a message called as path switch request after the handover is completed, target eNode B is sending a path switch request message to MME. Then what does MME do? MME says, okay, mobile equipment moved into a target eNode B, is reporting new tunnel IDs for his existing bearers. What do I need to do? I need to inform this to the S gateway by sending a message called as modify bearer request, letting the S gateway understand that the mobile equipment has moved into a new eNode B, and the S gateway should stop sending the traffic to old eNode B tunnels, and it should start sending the traffic to new eNode B tunnels that are reported in this modify bearer request message. Yes, gateway, if he accepts it, it will be sending modify bearer response. But at the time when we have issued this modify bearer request, if S gateway decided to change any tunnel IDs that he has created already towards P gateway, then it can be actually forwarding modify bearer request to P gateway and getting the acceptance from the P gateway. But this part may be there or may not be there. The second section that will be dependent on whether S gateway wanted to change its tunnel towards the P gateway or not. If it is not doing it, because anyway it is not required in most of the cases, yes, gateway will not touch this message directly when he receives the message from MME explaining him that eNode B tunnel ID details are changed now. Yes, gateway will simply send an acceptance. So that is why you see here and or. That means if MME sends a message to S gateway, and we may involve a message from S gateway to P gateway also. R means it may not be involved. S gateway to P gateway, it may not be there. This modify by request may not be present in R section. So mostly this modify bearer request will be needed to be reported at the time when any tracking areas are happening or handovers are happening, etc., etc. In such cases, we need to send this modify bearer request reporting eNode B tunnel details. The same modify bearer request we have studied in our picture here, if you remember. So once S gateway gets the create session response to MME, what does MME do? MME informs the S gateway tunnel detail, user plane tunnel detail to eNode B. eNode B creates the radio bearer. eNode B creates his own tunnel details for receiving the traffic from S gateway for in the downlink direction. By including these tunnel details, eNode B responds back to MME. What does MME do? MME forward the information to S gateway in the form of modify bearer request. What details will be included in the modify bearer request? This eNode B tunnel details will be included in this modify bearer request message, reporting S gateway that hey, you already provided your tunnel ID details in the create session response. I have already sent it to eNode B. Now eNode B created his tunnel to receive the downlink traffic. He sent it to me. I am sending it to you, and you note it down. You note down the eNode B tunnel details. If you receive any downlink traffic from P gateway on your S5 tunnel, you please forward the traffic to eNode B on eNode B's tunnel that is created by eNode B. You do that. I'm informing the tunnel created by the eNode B to you. So that is the purpose of this modify bearer request. Okay, so in various uh, situations, we'll use this modify bearer request to update the tunnel details on the, especially on the radio part. Radio part tunnel ID changes to report it to S gateway. We use this procedure. When the mobile equipment is going for a detach, then a delete session request will take place. Delete session means mobile is detaching from the LTE network. So at the time of attach, session request is sent to create both control plane tunnels as well as user plane tunnels. But control plane tunnels will be removed only at the time of mobile equipment is detaching or mobile equipment is at least detaching from one PDN. That time we will be sending a delete session request to delete the control plane tunnels, and corresponding PDNs user plane tunnels also will be removed. Delete session request. So Control plane tunnels can be impacted only with create session request and delete session request. Control plane tunnel IDs will be created between the components with create session request. Those tunnel IDs would be removed with delete session request. But with user plane tunnel ID things, you will never touch control plane part. So control plane tunnel IDs always will be created or deleted with session requests, either create session or delete session. But on contrary to this delete session request, we have an opposite procedure called as delete bearer request. What is the meaning of delete bearer? P gateway is triggering a delete bearer request to S gateway. S gateway is forwarding it to MME, and MME will send ERAB release request towards eNode B. ERAB release request towards eNode B. eNode B will send RRC connection reconfiguration, releasing the data radio bearer DRB. It will send, and once mobile accepts the DRB release, eNode will send ERAB release response to MME. MME send delete bearer response, and delete bearer response will be forwarded to P gateway. This is to delete dedicated bearers that are already created, which are now useless. Mobile equipment decided not to use those dedicated bearers anymore. The corresponding application has been terminated. You don't need to use that bearer anymore. You are deleting it. In this case, which tunnel IDs will be removed is only user plane tunnel IDs will be impacted. Only user plane tunnel IDs will be removed, not control plane tunnel IDs. Control plane tunnel ID removal is only possible from by initiating a procedure only from MME. That's all. P gateway cannot do it. P gateway can only create user plane tunnels and delete the user plane tunnels when we don't require those EPS bearers, when we decided to release those EPS bearers, the dedicated bearers I'm talking about. So that is delete bearer request and delete bearer response. And if eNode B proposes to MME that one bearer need to be released due to my load related problems, MME accepts it, and MME sends a command suggesting the P gateway to trigger the delete bearer request. So this command is basically to trigger delete bearer request. MME is starting this delete bearer command trigger because it has received a message from eNode B suggesting that I am facing a lot of load. This mobile equipment is having 5 EPS bearers. I wanted to release one bearer and reduce a little bit of load. Can you please help me? eNode B requested MME. MME says, I can definitely help you out with that. It sends a delete bearer command to S gateway. S gateway will send it to P gateway. P gateway will trigger the delete bearer request. As part of it, MME sends ERAB release request towards the eNode B. eNode B will trigger RRC connection reconfiguration request towards the mobile. Mobile responds back, ERAB release response, delete bearer response, delete bearer response. You will be releasing the user plane tunnel IDs again. So this delete bearer part, either it is going to be a two-step procedure or a three-step procedure. If P gateway himself decided to release the bearer by detecting the corresponding situation that the mobile is not using anything, then he will himself trigger that. Otherwise, if MME sends such a proposal, it will trigger this delete bearer request to remove one EPS bearer, dedicated EPS bearer. Default EPS bearers will be released only at the time when the mobile equipment is detaching from a PDN or detaching from the LTE network. They won't be released in normal cases because default EPS bearer having is mandatory for the mobile. We will not be deleting it with delete bearer requests. I'm talking about default ones. Only dedicated ones can be created, deleted. Default bearer will be created along with the attach, and it will be released along with the detach. Default one. Update bearer request. So what is this update bearer request? If P gateway is finding out that one bearer's quality of service need to be modified, so then it will be triggering this procedure to S gateway. S gateway will send update bearer request to MME. Here the tunnel IDs are not changing anything. Only quality of service properties are getting upgraded for the already existing bearer. So there is nothing related to tunnels here. Okay, so this is just to change the existing quality of service. Maybe P gateway got a indication from the PCRF that for this particular user, QoS need to be upgraded. Once you get such a request, P gateway will trigger update bearer request to S gateway to MME. MME trigger ERAB modification request to the eNode B. ERAB modification request. It will send to eNode B. And as usual, eNode B sends RRC connection reconfiguration request to mobile by making the changes to the existing DRB to add modify list. It will include the modification for the DRB quality of service. Once mobile accepts that, eNode B will send ERAB modification response back to MME. MME sends update bearer response, informing P gateway that for this particular bearer all across the path, we have changed the quality of service to the new QoS parameters. Now, this quality of service parameters can be changed, can either be triggered by P gateway on his own, or when uh, when HSS informs about this quality of service change to MME, then MME triggers this command procedure towards S gateway and S gateway to P gateway, suggesting this quality of service changes, because MME received a command from HSS that mobile subscriber information has been changed. According to the changes in the subscriber information, I am proposing for QoS changes. It sends a command to S gateway to P gateway, then P gateway triggers the update bearer request. So any changes related to the dedicated bearer or any creation of the dedicated bearer, modification of the dedicated bearer, deletion of the dedicated bearer, everything must be starting from P gateway itself. So if MME proposes this, P gateway sending update bearer request, and again it goes to eNode B to the mobile. Then once mobile replies back, eNode B replies back, MME sends the message to S gateway to P gateway by making modification to your quality of service parameters that are created earlier are getting changed upon the interest of HSS. HSS initiated subscriber quality of service modification procedure. That means if operator is making any modification to your user profile in the HSS, these things will take place. Okay. So there are a lot more procedures which we have to study in GTPC. We will come back in our next class and continue with that part.